All right, now we want to talk about how do we solve an inequality. And remember, an inequality is different from an equation because an equation says two sides are equal to each other. An inequality is saying that one side may be bigger than or equal to, less than or equal to the other. So it's slightly different. And what I want to do is I want to look at, okay, let's go through some different cases and see if doing different things to both sides of the inequality still makes it a true inequality. So we start off with the inequality 4 is greater than 2, which of course it is. What happens if we add 2 to both sides? So if I take this and I add 2, is that still true? And we see, sure enough, yep, that's still true. So what happens if I take that and instead of adding, I subtract 2 from both sides? Well, once again, we see 2 is greater than 0. Well, that's true as well. Well, what happens if I take that and I multiply both sides by 2? So I take this and multiply by 2, and I'll get 8 is greater than 4. That's still true. Well, what happens if I divide both sides by 2? Well, 2 is greater than 1. Well, that's still true too. So it looks like it's always true. But notice we've always worked with a positive number. What happens if we work with a negative number? Like I take 4 plus negative 2. Well, does that make a difference? Well, 2 is greater than 0. No, it doesn't seem to make a difference, and as it turns out, it doesn't. Nor will subtracting, but let's multiply. What happens if I take this and I multiply both sides by negative 2? Now I'm going to get negative 8 is greater than negative 4. Or negative 8 is greater than negative 4. Wait a second. That's not true. Negative 8 is not greater than negative 4. It's actually smaller than negative 4. So we've got a bit of a problem here. When we multiply by a negative, it seems like we got to flip that sign. Now, what happens if I divide by a negative 2? Then I'm going to get negative 2 and negative 1. Now, is negative 2 greater than negative 1? Nope, that's not right again. Negative 2 isn't greater than negative 1. It's actually smaller than negative 1. So what you'll see is basically when I'm solving an inequality, we're going to solve it the same way that we do an equation. But here's the big exception. If we multiply or divide both sides when we're solving by a negative number, okay, that's when we must flip the sign of the inequality. Now, let me stress again, that's when we multiply or divide both sides by a negative number when we're solving. That's when we flip the inequality sign. Okay, so let me show you how that plays out. Here's our first inequality. So I have 2x plus 3 is greater than 15. So I'm going to solve it just like I would an equation. I want to get that x by itself. So whatever's been done to the x, I'm going to do the opposite. So here's what I've got. So I'm going to start off by subtracting 3. Now, subtracting, adding, subtracting, we never flip our sign. So I get 2x is greater than 12. Now, I don't want to know what 2x is. I want to know what x is. So I divide by 2. Now, notice I'm dividing by a positive. I don't flip my sign. So I have x is greater than 6. So how do we show that? Well, we put a 6 on our number line. Open circle, because remember 6 isn't included in the solution. And then I shade all the numbers that are bigger than 6 and draw that arrow. Now remember, by shading everything, that's saying 6.1, 7, 8, 8.3, all those numbers are included. All right, what about this one? So I have 2 minus 5x, and that's greater than or equal to 7. Now we got to watch because the x is second here, but I want to get rid of that 2. Now one of the common mistakes is students say, well, I'm going to have to, since I'm subtracting 2, I'm going to have to add 2. But that's not true. If I look, this is actually a positive 2 minus 5x, or I like to think of it this way, as a 2 plus a negative 5x is greater than or equal to 7. So I got to get rid of that 2. So I'm going to subtract 2 from both sides. When I do that, I will get negative 5x is greater than or equal to 5. That's a funny looking 5, but it's 5. So that's what negative 5 times x is greater than 5. So I'm going to have to divide now by negative 5. This, since I'm dividing both sides by a negative 5, that's when I flip my inequality sign. And I'll get x is smaller than or equal to negative 1. So my negative 1, remember, it's smaller than or equal to, so negative 1 is part of my solution, and everything that's smaller. So that's how I would show that. Okay, let's take a look at a third one. Now the equation is getting a little more complicated, but remember we start off by simplifying both sides of the equation now. So before I start moving things around, I'm going to make both sides as simple as I can. So to do that, I'm going to start off with, I have 3, and then I'm going to take that negative 2 and multiply it through. Now wait, if I multiply it now, here's the big thing. I'm not multiplying both sides by negative 2. I'm just distributing that negative 2 through the brackets. So I'm not going to be flipping the sign here because this isn't one of those special cases. So I get negative 2x minus 6, and that's greater than or equal to, or sorry, greater than negative 6. Now I still want to simplify this side, so I have negative 2x, 3 and negative 6 is negative 3, and that's greater than negative 6. So now I'm ready to solve it. So to solve this, I have to undo what's been done to the variable. So it's a negative 2 times x minus 3. So I'm going to add 3 to both sides. I'll get negative 2x is greater than negative 3. Now, negative 2 times x, so I'm going to divide by negative 2. Notice I'm dividing both sides by a negative 2. That's when I flip my sign. So my sign has to be flipped. Negative over negative gives me a positive 3 over 2. So positive 3 over 2 is my important number. It's not included, so I put an open circle and I shade this way. All right. One last thing. So you notice it's very similar to equation solving with that one exception. This one looks a little more complicated again, so I'm going to have to start by simplifying both sides. So I'm going to get rid of those brackets. So 2x plus 6 minus 4 is greater than or equal to 5x. Now, I think of this as a negative 1. Or if you think of it as subtracting that thing, remember you subtract, you add the opposite. So suddenly it becomes a negative 1x and a positive 4. So either way you think about it, okay, we're going to switch those signs. Now before I start moving things around, I want to make both sides simple. So this side is 2x, 6 and 4, negative 4 are like terms, so I can combine those to a positive 2. On the other side, 5x and minus 1x are like terms, so that's a 4x plus 4. Now, I like to move the smaller variable. So in this case, I'm going to subtract 2x from both sides. So before I start solving, I get my variables on the same side. So 2 is greater than 2x plus 4. And now I work on that side with the variable. So I subtract 4 from both sides. I'm going to get a negative 2 is greater than or equal to 2x. Divide by 2. Now remember, when I'm dividing by 2, I don't flip my sign there. So I've got x. Now when I read this, this is a little strange because we're used to having the x on the left-hand side. Now I've got negative 1 is greater than or equal to x. Or if you read from the x is smaller than or equal to negative 1. So remember, the alligator is going for the big one, so negative 1 is bigger than x, or x is smaller than or equal to negative 1. So show that, negative 1, shade it in, x is smaller than that, so we would shade this way. All right, so the big thing to remember, if you multiply or divide both sides of an inequality by a negative, you've got to flip your sign.